So you're probably wondering what this app is all about and what you can get out of it. So I'm here to walk you through how it works. This is a Streamlit app for object detection tests of models trained with Roboflow Train. So essentially this first page, this home page, it's a multi-page app, is just showing you a centralized set of resources we have to help you learn more about the platform, ask any questions that you need, or keep up to date with our latest improvements. Then it's a quick explanation of what Roboflow even is, and a little bit about how the code that was used to make this app came to be. Some of the key features of Roboflow are also included, and then how, if you were needing more things such as more training credits or more image storage space, how you can access that based on the type of project that you're working on. So this next page we go to, this About page. So we get you started in computer vision by connecting you to some of the basics if you're needing to learn a little bit more about how it works. And then also about how you can get some images to get started if you don't have images already collected. The next thing we have here is how to train a model with Roboflow Train, and then also testing your model with the Deploy tab itself. So this video I'm recording now is going to then be placed right underneath where it says here, how to use this app. So to walk you through exactly what I'm going through now. And then you can see these next few videos on what object detection is, what image classification is, and also what instance segmentation is. That way you can get up to date with what we're even talking about when we say computer vision and the different project types. And then we have some great blog posts down here as well to walk you through some more of the computer vision problem types. Next, we go to the actual app itself. So what you're going to do here, the way this makes testing your model easy, is that this just shows you how you can truly customize what you've made with your model into whatever solution you're looking for. So everything that you're creating is your own. So I'm just using Python code to create this. And you can actually see that here. I've pulled that now into the screen. So this is Markdown. That is the directions. But then the actual app itself is written in Python code. And this is in a public repository for you. So we go back here. The way this works is what I'll need to do is copy my project URL, or you can copy an actual URL from Universe after you select a specific dataset version from a trained model. Just remember you have to use a trained model version, just anything with a green check mark next to it. You're going to copy and paste that here. Then you're going to go ahead and get your private API key. If it's from Universe, you can go ahead and grab that API key down here. I'm going to go ahead and revoke mine after this since you're seeing it now. And then if it's in your actual workspace, all you need to do is come over to your workspace settings, click Roboflow API, click copy. Remember not to reveal that private API key to anyone. And if you do, be sure to revoke it. Then you're going to paste it here. I've made it so that your API key won't be revealed. And then you're going to select a test image. So PNG, JPG, or JPEG file. So I've picked one here. Then you're going to select verify and load model. And then your app is going to go ahead and run. It's going to give you your inference endpoint for your records. Remember, this is only for the object detection project type, so I have a check in there to make sure that you are submitting an object detection project. You can see the project type here on Universe. You can also see it under each specific project within your workspace. It lists the project type and on the project page itself. So the next things we have are the version name, which is dynamically updated since it's going from a REST API route. Same with your model ID. And then the pixel width and pixel height you used when you actually resize the images for training. So you can see for me here, I use 640 by 640 for my resize. So we see those metrics here. We also say whether the version was trained from a checkpoint or trained from scratch. And then you have the uploaded image here and the inference results here. So because my settings here were set to a confidence threshold of 40%, overlap threshold of 30%, I know that I'm predicting at a confidence threshold of 40%, show me all the faces you can find, because this is a face detection model. And then any bounding boxes that overlap any more than 30%, it's saying to combine those into the same detected box. I also have it selected to show the bounding boxes. And then this amount of blur isn't coming in just yet because I'm not asking to blur the boxes. And then I get to show whether I show the class labels or not. If I display the bounding boxes as regular boxes, filled boxes, or blurred boxes, the width of the bounding boxes, the thickness of them, then the thickness of the label text itself. And the next you see here, the prediction results. So I've made this in a pandas data frame here for you. So you see the class of each prediction, the confidence, and then the points, the x0, x1, y0, y1, so that you understand how the bounding box is actually drawn, the width and the height of each bounding box, the region of interest of the bounding box. The region of interest comes into play when you're doing something such as blurring boxes, so that you're understanding that region that needs to be blurred. And then the bounding box area itself, in case you're interested in that, in case you were doing size measurements, if you had a reference object in there. You also get the code that was used to generate this actual prediction. So this is dynamically updated too, based on everything you select here, to make it more intuitive of how it all works. So I have the link to the documentation on how you can find out more. Then next, you see the JSON response output from every single prediction. So that's also where that data is coming from to make this plot in this chart, as you see here. So the predictions, this gives you the center point, the XY points of each box. And then I do the necessary transformations, as you see here, to create the x0, x1, y0, y1 points, and then create the starting and the ending points of the box, which is drawn this way. And then that helps me create the cv2.rectangle, which is that OpenCV library, to actually draw that box. And then I show the image. Then finally, you see the project info. See the number of augmented images in your training set, the total number of images in the version, your training scores for the loaded model, the training set, validation set, and test set image count, how much you augmented the images by, and for the valid and test set, there'd be no change because augmentations are only for your training set. You also see the pre-processing and augmentation steps that were applied. Okay, so let's go ahead and make some changes here. So let's say display bounding box as fill and verify and load model. And what we get here is filled bounding boxes. And you also see underneath those filled bounding boxes how our code is dynamically changed. So the thickness here, changing to -1, is saying fill the bounding box. And if we were to change this to blur and then do hide labels, we do verify and load model, we don't get any labels, we get the blurred boxes, and then we can say whether we want to show the bounding boxes or not as well. Then we get the dynamically updated code. That region of interest I mentioned from up here earlier, that's what's being used to actually blur the necessary area. And then here's how we're blurring that area. So high amount of blur, that ROI is here. If we do a low amount of blur, and let's say take off show bounding boxes, and we see here no bounding boxes, regions of interest are blurred. We also see in our code that the amount of blur has decreased. So that is how you're going to be able to use this app to test your model and see how things are running, and see more of how you can actually customize your end solution with whatever it is you choose to make with your model on Roboflow. Thanks for watching.